So we start at showing some things that are in the AI fairness toolkit. Some things that, let's say, gereedschap tools that can help to with making AI fair, robust. I'm going to show one more example of that, and then I'm going to do an example of a surface that's, let's say, keep an eye on the model surface. And IBM named it Watson Open Scale or AI Open Scale. Terrible name, if you ask me. It's keep an eye on the model surface, and I'll show an example of that part, how you can keep an eye on the model, because a lot of things can. So that's it. So first, a part of the explainability, and so again, this is an open source tool. You can use it yourself in your own notebook with Python. This is just a web application to click it and get a quick glimpse of what it is. So this is what I'm going to try to do, try the web demo. And this is about, let me make my screen a little bit bigger, about, I think, loan application. So during the break we had a little talk about this. My credit card was once declined when I asked for a credit card, but this was when I just got my first job. So when I was a student, I got one almost automatically. Then I got a job and I couldn't get a credit card, and I still don't know why, because I thought my data should be better. And then you explained to me that I should go through a different route, and then it was okay. So there's weird systems. And this is similar. So can you get a loan, yes or no? And let me, I can choose a consumer type. Let me be the loan officer. So I am the one that is telling the client yes or no, you cannot get a loan. And there's some model that put people as approve or denied. And here we see one tool of the AI Explainability 360, Proto-Dash, which is, I think, one of the most beautiful ways to explain something, explained by example. That is a little bit how I went through my study. I didn't understand it. Give me an example, and then, okay, now I understand it. So humans are really good to learn by example and explain by example. So let's see why Robert was denied. And this specific tool, Proto-Dash, is telling, well, Robert, you are denied. And the loan officer, so the guy from the bank, can say, well, I can see, because Robert looks a lot like James, and he defaulted on his loan. And every metric that is exactly the same is here marked in blue. And without any complicated metrics, debiasing, this is just a very easy way to explain a decision. And here I think is a way that AI and machine learning can already help a great deal. For instance, sometimes we talk about tumors. Can AI detect cancer? And that all looks very scary because we don't want a machine to tell us if we're healthy or not. But I would be really, really comfortable if the doctor that assigns me gets 3 or 5 examples that are really similar to my case with the result of what happened there. And then that feels like a really safe step in between for me. So even though it's really simple, just so similar results, I think there's already a lot of power there. And sometimes with AI we always want more complexity because more complexity equals better business results. That's of course nonsense. Sometimes it's very easy with a simple thing we can get a lot of value. So this is that I want to show. Proto-Dash just shows similar things, and that can already be of great value, even though the tool itself is not that complicated. Okay, and this is again from the open source. Now I want to move to the open scale, but not before I give. I want to tell a few more things. This is the first time that I saw something about models being biased in the Netherlands that made the news. It is in 2015, and I think it's a real funny example because this was home insurance, and based on the, how to call it, postfix of your house, suddenly you could pay €134 more a year. So, example, I live at number 44, I pay 1,000. If I live, my data is exactly the same, but I live at number 44A, sorry, 1,100. That's €100 more because the model learns that a postfix layer is more risk. And this was funny because I thought, oh, I put the radio a little bit louder. Let's say what they say about this. Of course, they asked the insurer in case, and they said something like, yeah, our models are complex and we don't disclose any of the inner workings. They give some blah, 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 like that, but it made the news. And what also is the whole, this was not good publicity for this insurer. This was bad publicity. So I am sure that if they knew it before, they would probably fix it if this can cause such a bad negative publicity. So maybe a few people changed their insurance or something, but this is in 2015, it already happened. So that is one thing. Another thing that I sometimes ask as an introduction, that this is a bad order, this should be maybe at the beginning, but who thinks it's fair to that your age is depending on the price you pay for a medical health device, for instance, glasses, but that is the promotion of some companies that sell glasses. They say your age is your discount. So that's a whoa. Wait a minute. We're talking about values and health. I thought it was fun. And what I also, this is all what I showed. This is a few examples of tools that Dasha already mentioned. This here is Shop, but let's start with Line. This is maybe the first popular Python package that was able to explain model transactions. So not the whole model, but why this person was on the left or on the right, and also for images. This one is, let's say, the younger brother of Line, Shop. Sierra, Hotel, Alpha, Papa, Shop. And that one is doing similar things, but it looks more modern. See, this is maybe old, very primary colors. This is more pastel tones. The visual more attractive, and it also has some few extra features. I tried them both. Very fun. Shop I used on a model to predict how good a recipe is. So from Kaggle there is a Epicurious data set, a lot of recipes and how many stars each recipe gets. I made a model that predicted how many stars the recipe had, and then I put it in Shop and tell, please explain to me what makes a recipe 5 stars or 1 star. And Shop explained to me fat and calories. The machine is telling human, you like fat and calories, so no news there, but it worked, because that's what, more or less what I expected. Okay, so as a last, a little demo of the keep an eye on the model service, which is AI Open Skill. Yeah. So how does it work? This is the web interface, but there's also a Python API tool. So this is just a web interface, but you could programmatically do all those stats and see all the metrics that you see here. You add a model to the dashboard. There's already a sample model, but for instance, I made a model that predicts the house price for properties in Madrid. I scraped some data from Fotocasa, which is the Spanish funda, I don't know what to say. So from Fotocasa, take a look and then try to build the house. And I can feed it to OpenScale, and literally what OpenScale will do to me, it will keep an eye on the model. And here there is a sample model, German credit risk. At least for AI fairness, we should come up with more examples, because all I see is a credit risk all the time. But here, I want to talk about a few things that's happening here. So fairness, you see here age and sex. Of course, it didn't went automatically, because the whole idea was first we should agree what is fair. Once we agreed, and I learned today this should be for each country, for each use case. So what's fair in the Netherlands is maybe not fair in even a neighbor country like the UK or Germany. And once we agree what is fair, we have to tell the model, please be fair on this. And then once the model is being told on which attributes it can be fair, it can keep an eye on it. So apparently this model is not fair for the attribute sex because of something. Here's quality. That is what we always want to know. Is the model still good? And this one is one that I find really interesting, drift. And for that I've taken a little bit candy. Because when I was young, I really liked this Haribo. You also like them? Yeah. This is the Haribo Happy Cherry. And I was so happy when I was allowed to eat a few Haribo cherries. You also like them? But now I will reveal my age. I'm 36, and I never buy them anymore because they taste like sugary gummy with artificial. I think they're called esters in chemistry. They changed the candy. Right? That was what I thought. They changed the candy, because this cannot possibly be the same. Of course, it's still the same candy as years ago, but I changed, right? My idea of what is nice changed over the years. So I don't like them anymore. But you're still a kid, so do you still like them? So the data point is still the same, but somehow I don't like them anymore. I also have bananas. There was another little boy. He left. He's still there. He left. Then I keep those. Bananas still pretty alright. But what I want to say is, I had a discussion with my friends. Did they change? Because also there was ice creams like Magnum. I think it's now a package of butter with a tiny little chocolate. How did I like it? Did it change? Well, that is the topic of model drift. Sometimes we talk about model drift. And then if you're not too familiar with machine learning, AI, or how we talk about it, it feels like, oh my god, the model is drifting away. The model is changing during its so for instance, a model will predict what kind of smartphone a person likes, and then oh no, it's only saying the iPhone 6, why it's not there's an iPhone 7. If we talk about model drift, the model is not the thing that's drifting, it stays the same. Just like the candy. The candy didn't change, it's just the same. It's the data points around the model that is changing. What went in is changing. So in the documentation, or maybe some blogs, you see the term model drift. So I want everybody to realize here, the model is staying where it is. Usually the model doesn't move an inch unless you actively tell it to retrain or reinforcement learning. But in practice, that doesn't happen. In most cases, the model is set in stone, and maybe some models are being retrained. So model drift doesn't mean that the model is changing. It actually should be called data drift. So in this case, I am the data, I am changed. And this is something that is being detected in the AI fairness. And here we see the drift, and we see two metrics here. So here, So, you can click a few data details, but I want to tell, because I thought it was fun how this is being done. We see two drift metrics, the drop in accuracy and the drop in data consistency. I'm not going to talk about the credits anymore. I'm going to talk about something more fun, house prices. With Mondo, we actually did a hackathon, right? You still remember? About trying to predict the price of a property in Madrid. It was Madrid because the hackathon was in Madrid, so we thought let's predict Madrid in Madrid. And we found out there that some houses are really easy to predict and some houses are difficult to predict. There was a team that found out that if it has more than 8 rooms, it's really difficult to predict the price of the house. And I guess, I don't know if it was 8 or 10 or something, but there was some threshold that if the house, let's say 12, has more than 12 rooms, suddenly the model has a lot of difficulty with predicting the price. And this is maybe explainable to us once we know it, because yeah, well, if the house has a lot of rooms, it's maybe not normal anymore. It is maybe not a common house anymore, so it is always an exception. And that might be the reason why houses with a lot of rooms were difficult to predict. And it was very easy to learn this, because the steps are pretty like this. We have the data, we make a version 1, a baseline model, and we simply check in our training data which type of data was pretty easy to predict and which type of data was difficult to predict. And then by doing this little exercise you find out that, hey, my model has difficulty with houses with a lot of rooms. This little exercise is actually always good to do, because if you want to make a sharper version 2 with better accuracy, there's a lot of information in the data points that were difficult to predict, because usually there is some cloud of data points that is easy for the model to predict, and there's always this little glow around where difficult edges, where the differences between a very good model and a good model. So this is anyway a good exercise, but also in data drift. And this little drop in accuracy is calculated exactly in this way. There is a model that Skill AI keeps an eye on, but by looking at the training data, so it needs access to the training data, it has learned, hey, this model works really well for houses with less than 12 rooms, but it doesn't work so well with houses more than 12 rooms, and including 12, otherwise I miss houses with exactly 12. So that's how this works, and if the input is houses with more than 12 more over time, so maybe in the first week that was about 5%, but in the second week it was 10%, and in the next week almost all input is houses with more than 12 rooms, you suddenly know, wait a minute, my model might have a lot of difficulties with handling the inputs that is coming right now, right? Because this is what I know my model has difficulty with. So that is this drop in accuracy. And why this is, well, the thing is, it might still be data very close to data within your training set. So what I want to say is, realize this is not something like the data is different from the training data. No, no. The points might be very close to points actually in your training data. It's just that within the training data, the model had problems to predict this kind of data points. So that is this drop in accuracy. Another one, drop in data consistency. This is the second one. The training data and the data that goes into the model might also drift. So, because the model was trained on houses with these properties, but maybe suddenly there's a lot of houses that are very different from the training data. That's also a little light that you want to warn. All right, the data is different than the training data, so here things can go wrong. So that is another metric. And then because of these two metrics, it's also able to estimate the accuracy, because it knows a little bit on this type of data I do pretty well, on this type of data I don't do so well, so it can also estimate the accuracy for a given time. So that is data drift, but sometimes in the blogs or you call it model drift, but just be aware, it's not the candy that changed, it's me, it's not the model that drifted, it's the data that went in use. And another thing to mention about this, I had a discussion with somebody who studied philosophy. Yeah, yes. And we talked about that it's very good to know human traits, because usually data is about humans. And in my experience, if you have a model that predicts something where humans are involved, the drop in accuracy is almost a certainty. You just don't know if it's a week, a month, or a year, but for sure it will change, because humans will change their behavior. And like the predicting somebody's next phone, next year there will be an iPhone 12 or 13 and a Samsung Galaxy 8 or 9. 10, I lost count. But if you keep the model the same, it will make it will be wrong, because it has to be retrained. If you make models on machine or mock data, there is also a drop in accuracy, iteration of the model, but in my experience a little bit less fast than if it's about humans. So there's always this drift, but with things related to humans a lot, so that's why it's indeed good to have some common sense about the data points, these humans, but with machines there's also this. So this always happens. At some point you need to retrain your model. So this metric helps. Another one. Let me see. We can, yeah, this is another fun thing. There is a de-biased and a original metric. And the de-biased, I think this one, but I need to check the documentation on this, is a very easy bias mitigation technique, I should say. So you know the model is not fair against age group lower than 20. What can we do to make it more fair? And one way to do this is to, well, this person is applying for a loan. He is indeed young, 20. Let's just change his age to 60, and then you will be treated as a person who is 60, even though you're 20. And then you change his age to 60, then you feed it into the model, then you get a result. It's a very easy bias mitigation that of course has its pros and cons, but I think that is the one that's being used right here. And then, okay, there's bias and a de-biased one. Then we can go to explain transactions. So again, this doesn't explain the model, but a single transaction. Why a person was declined this loan is taking a time for it to calculate, because how it works right now, it's feeding the model with all kinds of variation of the original data points to test its sensitiveness, for instance, on age or yes or no, a certain feature. That's why it took a while. Sometimes you don't need to do this, because if, for instance, the model is a simple linear model, you know the weights, so you could calculate this in a millisecond. But the AI open scale works with all models, so it works not by inspecting the actual model, but it works by keeping an eye on what goes in and what comes out, and by changing the data that goes in. Here somebody was not at risk, and here you can see the most important feature that contributed him for not having a risk. So in this case, this person didn't have any other loans, so that's why he didn't have a risk factor. In this case, his loan duration was 18, which is probably short, and that was another factor that contributed him to have a low risk for the loan. Another thing. Okay, here's another one. But in case of a risk, for instance, this person, he might ask, wait a minute, why am I predicted as risk? I think I am pretty good. Can you please tell me why I am at risk? And well, the loan agent might tell him, sorry sir, but you did a loan of 37 months and you're a little bit old. That's why we declined your loan. And then the person might ask, what can I do to make sure I get the loan? And then these are the minimum changes in the terms of data. So the loan can tell, well, you should use a time machine and become 36, and installment percentage should be 3. Well, of course, this doesn't make any sense, but from a reality perspective, because he needs to become younger. But these are, it is a funny feature that it tells, okay, the closest line to flip from risk to no risk would be in that direction, and that is by changing the age to 36, etc. So that is another feature of this AI 360. All right. Last thing I want to tell is about, did I already mention Weapons of Mass Destruction, this book? Okay. Yeah?
Oh yeah.
Oh, not for everybody? Okay. That is the book on the left. There's a lot of books about AI ethics and etc. This book is by Katie O'Neill, and I really like the book. It's not a fun, happy book. She's a little bit give human in your face what's happening, what's wrong, and not come with a lot of solutions. So she's a little bit on the dangerous side, how to say, negative. She does, her faith is not that high in humans. But I really like the book, and in the beginning she tells that she's studied, I think, mathematics or economics, and that in the later years she called that she rebranded herself as a data scientist, and then did the things she was doing with financial options, but now for other causes. And there she gives a lot of dangers that we can have by, well, she gives a few aspects of when AI can become really, really dangerous. And one of them is skill. And in the book is an example of the one that you mentioned, Dasha, of the compass, the system that is actually telling, should I be longer in jail or can I be free? That is the compass system, that's real, I mentioned in the book. Another one that I thought was really nice is the US list of the top universities, which I talked about in the break, where there is a newspaper that came with a list of the top universities in the United States, and if a university wanted to be higher on the list, they needed to check, wait a minute, how is this list being calculated? What is the model behind this list? And this newspaper told exactly the points how you get scored high. One of them was student facilities and gym and a swimming pool. So if there's a university that was low in that model, what they could do next year to be higher was, well, we gotta make a swimming pool for our students and a nice gym. It will cost $500 million. It doesn't matter, we just increase the student fee because that one is not on the metric, if it's cheap. So next year they increase their student fee, and they made this nice gym and swimming pool, and indeed they got higher on the list, and then you can imagine the war that this started, and at some point I think there was somebody that said, wait a minute, this is not going the right direction. But here, this is an example that fits in her model, in her four metrics that you should check, and one of them is mass. If a model is very large and it has a lot of influence on decisions that some data population makes, all you do is amplifying the history. You're not doing anything more than that. You're amplifying the history. So I happen to have glasses. If tomorrow every model puts people with glasses on the wrong side of the buckets for loans, for education, for everything, then the next day people with glasses are, of course, a step behind. We need to pay more for our mortgage, we need to have less education, and at some point this has become the truth, and then actually AI is an amplifier for history. And in this book there's nice examples for this, but also, fortunately, some sweet words about what you can do against it. And this is the book, but it's also available as audiobook, and Katie O'Neill is herself speaking this audiobook, and there you can hear some of her emotions when she's reading all the examples and how crazy this is. So that is a good tip for if you want to learn or read more about this. All right, that's it. Maybe some maybe some questions, and then
yeah, then closure.
And then closure.
And then some drinks. For those ones who stay for longer.
I have two questions.
Yeah, sure.
Yeah. So this alternate scale actually looks very interesting. But I wonder if the exploration of the model surface happens during the training on the fly or during the validation.
There's a few requirements. One of them is OpenScale wants to see the training data. That is quite a requirement, right? But it is needed to do some of the metrics. And for the explainability, I know, it's not involved in retraining the model. So there it stays away. But for instance, for the accuracy drop, so the model drift, which is actually data drift, it does create some models just to check which data points were easy and difficult to predict, but other than that, it's not interfering or changing the training process. The AI Fairness 360 toolkit does have some tools and metrics that are actually involved in the training process. But here, the OpenScale really works like this: training data and some deployment, which speaks REST. So this case was a model in the IBM cloud, but Google, Microsoft, Azure and Amazon are also supported, because again, it doesn't need to have access to the source code of the model. It wants to look at the training data, and by feeding the model and checking what went in and what went out, it's able to calculate all those metrics. Alright, for age, please keep an eye on that, and then OpenScale will say, alright, what is the, let's say, vulnerable group? What is the group that you want to make sure are not discriminated? Sometimes it's the young ones, sometimes it's the old ones. I think in the loan application it was the young ones that have a step behind, maybe because we are still immature, irresponsible, the young ones, and the old people are wise and sensible, so that's why. So you explicitly need to tell age, young ones is the protected group, and the not young ones are the reference group, and from that moment on you can keep an eye. And a very simple way to that trigger that something might not be fair is if in the original data it was quite how to say this now. If in, let's say, 100 people do an application, and you can simply look the proportion, how many of the young ones were rejected and how many of the not young ones were rejected, and if this proportion goes behind some metric, is a change of maybe more than 10% or 20%, it's nice to get a trigger. So this is one of the very simple counters that's being used to trigger you for these things. And that's also what I experience in most toolkits and bias mitigation. It is a very easy, common sense things that we use to try to make it a little bit more fair. And maybe that is because this is all about trust, having trust in the model and in data. So I also think our tools should be very simple, so we can explain anybody, not only the model creator, to explain what has happened and why is this now a warning. So only that way we can maybe do a step forward. It's really fun. We did there is a guy that's just left. Okay, we did a little hackathon on this. And here we have the zoo I call. These are some animals in the zoo. So probably there was a follow-up question. It's a wallet. Cheese into a wallet. Maybe these are easy to do the cheese wallet attack. Then I'm not sure. So actually I think they are because there's no robustness probably involved. But other than that, they did a pretty good job in making a nice overview of models and train them with quite good accuracy and host them for you to try out.
Okay, and
But no bias. Yeah.
so you guys did a research areas.
Yeah, it's feeling like my own mother that I did this question.